BlockChance Online Live is an online live-streamed broadcast talk show about blockchain, AI, and green technology. We bring inspiring speakers and innovative thought leaders together to talk about current and future developments within these exciting new fields. Join us to learn how we can use these disruptive technologies to better aid humanity and strive for a fair, secure, humane, and positive future. Get involved in our community and share your opinions and ideas. Together, we can make a difference.
Hello, everyone, and welcome to BlockChance Online Live. My name is Albert, and I wanted to start today's show with a short story that happened to me yesterday. So I was talking to a friend and explaining all the great stuff with blockchain, and I want to convince this friend how to actually use this technology. So the easiest way to use this technology is, of course, creating a wallet and sending some money. And I want to send $5, and I want to do this on Ethereum. The problem was sending $5 would cost me roughly $4. So it was a very hard sell. I convinced her with other arguments, with all the other use cases of blockchain, but it was very difficult to convince her that blockchain is ready for mass adoption, that blockchain can be used to transfer at least a small amounts. And this was even more difficult to explain to her once I started to mention that there are also other solutions in place. So she asked me, why are we using Ethereum then? And today we want to talk exactly about this question, because there are already solutions in place that tackle the scalability problem that Ethereum is facing, and that Ethereum is promising to solve in the future, like into the next 2 to 4 years maybe. And one of those projects actually implemented this technology called sharding back in 2019. And I'm very excited to talk about this, what this means, how it works, how we can already use it today. And yeah, I want to introduce our today's speaker, Dr. Amrit Kumar. He is one of the co-founders of Zilliqa. He is the current president of Zilliqa. And please say hello to the audience.
Hi there. Hi. Great to be here.
Thank you for being here. So what we want to do with this show is actually think together. So this means we want to educate the audience, and this means that they can ask questions. And this also means that we won't talk about any prices, because this does not matter here. So we are really interested in understanding how the blockchain, the Zilliqa, actually works, and what kind of advantages it brings, and also what kind of challenges you are facing right now. So would you please give us, first of all, a brief overview of the history of Zilliqa? How did it came to life, and what were the challenges back then that you solved?
Yeah, so this whole journey, I think, started sometime around early 2017, or probably a little bit earlier than that. It was when CryptoKitties were becoming popular. Ethereum was seeing some traction in the broader blockchain ecosystem and landscape. And ICOs had sort of started. And we were seeing people trying to transact on Ethereum, and they were stuck with their transactions because an ICO, maybe let's say EOS ICO was going on, or Tezos ICO going on, and so on. And therefore, it was challenging to see that a new platform that had just come up, and which was seeing its first sort of an adoption of some sense in terms of, let's say, crowd fundraise, was seeing the challenges of the underlying platform, that the platform was not able to scale, was not able to meet the demands of DApp or even users, to a point where, for example, when CryptoKitties went live, we are seeing the CryptoKitties developers trying to adjust their contract logic. So they were trying to minimize the features that they wanted to have for people to make sure that the underlying platform would be able to sustain the traffic. So this was kind of the world we were living in back then. And back then I was a researcher at the National University of Singapore. And my advisor and some of his students, one of them is now actually the CEO of Kyber Network. So these people were looking into this from a research angle, so trying to understand how can we solve this problem of scalability, how to make public blockchain scalable. And so they started to work on that, and the result was a paper on sharding, where the idea was to sort of improve the processing capacity of the network by dividing the network into smaller pieces, smaller subnetworks. So that paper was launched and it was published in one of the top security conferences in the world. And then my advisor was kind of thinking, okay, what to do next? You have this paper, and most academics sometimes just stay with one paper, publish that, and then move on to the next one. And he was more commercially minded, so he felt that, okay, what can we do with this? Can we actually put that into practice in real world so that we can actually see and build a platform where people can transact at a cheaper rate without worrying too much about the underlying scalability of the platform? And that's how basically Zilliqa started. So we and some of the founders who were back then still either employed at the university as a researcher or a PhD student, we all assembled together and we decided to work on this project, starting from the academic work, so academic paper that we had. But obviously, as you can imagine, the academic work is still very theoretical, but when you start to sort of implement that into practice, there's a huge difference. So the idea was to sort of our Zilliqa journey was basically from moving from that paper to an actual implementation. Along the way, we also collaborated with some other people, one more academic at UCL, University College London, on the angle of smart contracts. So around that time, we had seen DAO hack happened, and then Ethereum sort of fogged into Ethereum and Ethereum Classic. Very soon after, we saw parity multisig hack happen, where someone was able to freeze, $300 million, I suppose, of assets in that contract. So we're also thinking of looking at those problems in the space and see how can we fix those. And one idea that we had together with this professor and faculty member from UCL was to design a language, smart contract language, that would be able to make some of these mistakes difficult to have. So a developer will have to think twice before they would make mistakes. So these were two key areas where we wanted to focus with Zilliqa. One was scalability, and the second one was smart contract safety with a safer smart contract language.
Yeah, fantastic. Thank you for this overview. So in this perfect start to actually ask this question, what the hell is sharding? So we talk about this all the time. We hear it, especially in the context of Ethereum too. And I mean, you managed to actually implement this already back in 2019. So maybe also explain us, once we understand better how sharding works, how other projects might have learned from your real life experiences, as you just said. Because if you run something in production, you discover suddenly behaviors and patterns just not actually, or quite difficult to discover in theoretical terms.
Yeah, so we obviously, the way sharding essentially works is, you imagine, for example, today when you interact with Ethereum or Bitcoin ecosystem or Bitcoin chain. So as a user, you write a transaction, you say that, okay, I'm going to transfer my funds from my address to someone else's address. And that transaction then goes to the network. And then every single miner in the network, which could be 10,000 nodes, for example, even sometimes even more, will process that transaction. So even if, let's say, you're sending even a small value transaction, let's say $10 worth of transaction, that transaction has to be processed by every single node in the network. And that basically gives the ultimate decentralization that you can imagine. So even if, let's say, a few nodes go down or are unavailable or have been taken down by certain parties or certain governments, you could still have a network which is functioning, and you don't have to worry about your transaction being censored. So that's very powerful, very decentralized, but at the same time, it's somewhat also redundant, because even if the network grows to, let's say, 1 million nodes, you still have 1 million nodes processing the same single transaction. So in a way, that's wasteful and redundant. So the idea of sharding is basically to divide that network into smaller groups. So if, let's say, if you have 10,000 nodes, then you divide them into 10 groups, each containing 1,000 nodes. And then each group will be called a shard. So basically a piece of the broader network. And then let's say my transaction, whenever I send my transaction, that transaction will always go to shard number 1. And whenever you as a user sends your transaction, it will go to shard number 2. So what happens with sharding is that the more shards you have, the more transactions you can process, because then you are actually sort of applying this idea of divide and conquer. So you divide the network into smaller subgroups so that each subgroup can process transactions in parallel. So obviously, this general idea of sharding, it's well known in the database literature, and people who develop. I'm sure that Google, Amazon, and all sorts of data service providers, they obviously have sharding implemented in their systems. But it was not clear until our work that you could actually implement that into a public blockchain system. And remind you, these systems are very different because public blockchain systems are very adversarial. So anyone can join the system, anyone can try to attack the system, and sometimes people have have economic incentives to attack the systems. So it was a very different sort of economic setting in which we had to operate. And so we're glad to show to the world that sharding was a promising solution to work on if you're trying to solve scalability as a challenge. And obviously, soon after, we saw several other projects trying to adopt or improve upon the ideas that we put up initially. Whether it be, again, Ethereum is one of the biggest ones, which has been looking into sharding for quite a while now. We saw Harmony, we saw, and even Polkadot. You could argue that in a way Polkadot is also doing sharding, but it's in a slightly different way. We saw, I think, Near working on sharding as well. So at least one thing that we definitely showed to the blockchain community, that what we started with sharding is something that is believed now as one of the main stable ways of scaling blockchains. And that clearly comes out just by looking at the kind of number of platforms that are actually using sharding as a scalability solution.
So I would like to try an image here to further explain people that are not so into the tech what actually sharding means. So there is this joke question that a friend of me told me recently, where he asked me, how many Bitcoin miners do you need to change a light bulb? And the answer is that you need all of them, of course. And maybe we try to use this picture and imagine how would a world look like where sharding is utilized to change a light bulb.
Yeah, so imagine, for example, you have this light bulb is, in a way, in your example, it's a light bulb which is global in some sense. So it's a light bulb that basically lights the entire universe. Imagine, for example, like sun as a light bulb, right? So basically, in the Bitcoin world, you want every single miner to decide how to switch on or when to switch off that light bulb in some sense. And that has to be an agreement across all the nodes in the Bitcoin network. So well, it's very good because it's very democratic, it's very decentralized. Even if a few of those mining nodes decide that, we are not going to switch on the light, you still have someone willing to do that for you. But again, it's very, as you say, it's even as a joke, it sounds very funny because it's very wasteful, right? Now, a different model, that sharding model of this light bulb, will be that you will have multiple light bulbs. Like in an apartment, you have, let's say, 5 bedrooms, and each of those bedrooms will have a light bulb. And each of those bedrooms will have, let's say, 2 occupants, and those 2 occupants will decide how to and when to switch the light bulb. And that's kind of what sharding does, is that you divide the load or divide the decision-making power or validation power across different nodes so that they can make decisions more efficiently. And that's kind of what sharding does in practice. So taking your example, light bulb example, as a real-world example of how things work when you try to decide on something in a consensual manner.
Mm-hmm. And now if we take these different charts and you have something that you call micro blocks. So let's imagine these are the light bulbs that you turn on and off. But now we also want, of course, to have a global state somewhere that I can look up. Is my bedroom on or off, like the light bulb in my bedroom? And how do you actually do this?
Right. So there are different challenges. This is exactly where sort of sharding becomes interesting, because when you talk about, let's say, shards, you have these smaller groups. But how do you decide which node goes to which shard, right? Because if, let's say, the network wants to be malicious, it could say, okay, let's put all my friends into one bedroom so that they can collectively decide that, okay, there will be no light in that bedroom or in that room. So the idea is you need to assign very carefully nodes in different shards. So nodes in different apartment, in rooms in your example. And one idea to do this is through random sampling. So if you have, let's say, a large number of nodes, even if, let's say 1/3 of them are malicious, so they can arbitrarily decide and abrupt decision making, disrupt decision making, then what you basically do is you selectively and randomly select people from that bigger pool and assign them to different shards. And this is where you sort of, if your initial set is large enough, then you're basically saying that the probability that if the initial set you have only 1/3 of nodes which are malicious, then if you are sampling randomly with a large number, then you would still have the same guarantee even within a group, even within a shard. And so the question is, how do you do it then? So you want random sampling, but who decides that random sampling? Who picks that up? And this is exactly where we have a special sort of shard that we call DS committee, which basically does that work for you. So the way it works is you have people doing proof of work. They come up with that proof of work, as you know, has randomness in it. And though that randomness comes in, and these people basically look at that randomness, and based on that randomness decide where people would be assigned, which shard they will be assigned to. And again, the same way, talking about global state that you mentioned, when different shards sort of come out and say, okay, here's what we decided, that these transactions are valid, we need to build a sort of global state in some sense. So this special shard, the DS committee, basically sort of collects all of that information together and presents a broader and global sort of state of the system to everyone, so that everyone can basically sync to that global state. So that's how basically you reconcile, in some sense, the different state that are being processed across different shards, and then give a global view to everyone.
Okay, yeah. So just to try to summarize this once more, because I think for us, we heard these terms over and over again, so it's quite easy to follow. But for other people that are hearing this the first time, it's quite technical. So what we do in Bitcoin, we have like just one, if we take again this example of the light bulb, just one global light bulb, and everybody works on this. And just the one that is first done gets a reward, and actually seals the block. And the difference here with a sharded blockchain like Zilliqa is that you have like a house, for example, and in this house you have different rooms, and each room has its own rules, or not its own rules, they are following all the same rules, of course, but each room has its own validators to actually decide if you want to turn on or off the light bulb. And then you have what you call the DS committee that actually collects all these results and presents this to the outside world as a global state update.
That could be your living room, for example, where everyone becomes sort of sees what's happening in all the other rooms.
Yes, exactly. Okay, so now this is a good image for me to actually imagine how this sharding works. I mean, of course, this does not cover the full aspects of the problems that are involved in all of this, because this cross-chain or this cross-shard communication is especially difficult once we start to talk about state sharding, where you actually want to execute different smart contracts that actually need to communicate with each other. And this easy example, you just have like a light bulb that you want to turn on and off, like a transaction, let's say. But what you want really to run smart contracts, this problem gets much more complex. Could you walk us through this? What kind of problems are introduced once we talk about smart contracts?
Sure. So take a very simple example. I've been using that example for ages now. Imagine, for example, you're doing an ICO. So you're selling tokens for, let's say, Zills or Ether, and you have only one token left. Okay, so I'm talking about, let's say, the most degenerate scenario in that sense. So you have only one token left, and let's say you, Albert, and me, we are trying to buy the same last token, and assuming that the price is fixed, so whoever comes in first basically gets it. Now, you have two shards. So remember that because you have shards, you want to make sure that the same transaction don't get processed in the same shard, because otherwise you are not taking the benefit of the underlying sharded network. So what will happen is, let's say I send a transaction and I say, okay, I want this token, and you send the transaction at the same time, and you say, okay, I want that, you want that token, and these two transactions are supposed to go to two different shards, right? So my transaction will go to shard number 1, and your transaction will go to shard number 2. Okay. Now, how do we decide? So my shard will basically say, okay, Amrit sent us transaction, and there's one token left. Let's give it to him. While your shard will say, okay, I only see one token left, and Albert is sending his transaction. Let's give it to him. But then how do we make sure that this token doesn't get sent to two different people? So you and me both. So this is a very simplistic example where shards need to communicate, right? Shards need to talk to each other to show that, look, I am handling something that you might also be handling, and so be careful not to handle the same transaction in the same, not to assign the same state or change the same state concurrently. So that concurrent processing of transactions in a sharded state sharded chain becomes slightly challenging. And then again, take your example where you have to talk to different shards because there are different chains of transactions. So for example, when I call, let's say, a hotel booking or an agent transaction. So let's say you have an agency that does hotel booking and airline ticketing for you. So you reach out to this agent and say, I want to book a hotel and I want to book a flight ticket. Please do it for me. And so this agent maybe want to talk to a hotel contract, and he may want to talk to, I don't know, a flight contract and then want to decide something. So you can imagine the whole complexity that can come up when you have sort of more and more contracts sort of interacting the way DeFi works today, as more and more contracts start to interact with each other. So this whole problem becomes very, very complex in the sharding architecture. It's not as trivial as Ethereum, let's say 1.0 that people may call it today. It becomes very, 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 very challenging, and you have to figure out one. And there are different ways of solving the problem, but these are non-trivial in that sense that you have to figure out how to lock the state of a contract for a while until someone else comes in and says, okay, I want to take the lock because you are done processing this transaction. So these are certain considerations that we have to figure out, or we had to figure out, and other chains are figuring out as well, on when they try to run smart contracts on the sharding architecture.
And one way to do this, and I mean, most of the blockchains are working towards that, is improving the structure of the blockchain itself. But another way, or an additional way to actually do this, what you're also doing, is actually designing a language that allows for improvement in terms of speed and especially security, which has certain properties to enable this cross-shard communication in a less complex way or an easier way. So what are the actual reasons of developing your own language? Because this always introduces a lot of new problems. One of them is that nobody has any experience with this language yet. And but why do you still think that this is necessary?
Yeah. So the reason why I feel designing a language like Scilla was necessary, because we had seen incidents like DAO and parity happen. We had seen that when Solidity was designed as a language, and again, by the way, very recently the Solidity team did a survey. Before I could jump into Scilla, Solidity team recently did a survey, I think a few months back, and they were asking their developers and Solidity developers in the Ethereum ecosystem, what are the different aspects of the language that you like and that you hate. And one of the hated aspects of the language was that it was similar to JavaScript. And a lot of web development, I think probably most of the web development that happens today, it's all in JavaScript. And yet, people don't like the fact that Solidity was designed with JavaScript in mind, or with that flavor in mind. Now, coming back to a security perspective or security point of view of Scilla, when Scilla was of Solidity, when Solidity was designed, it was designed with the usability in mind. So the developers and designers of Solidity wanted to make sure that you could design all sorts of applications that you can imagine on using that language. And they didn't care that much initially, at least at the design level, they didn't care that much initially on the security aspects of it. So for example, when DAO happened, people very quickly realized that you don't want a contract or you don't want a function in a contract that allows you to go and talk to a different contract and then come back and then do something else. Because when you do that, it starts to include all sorts of issues with the language and state. So it can create inconsistent state for the contract. But why not stop it? Why not prevent that at the language level? What happened after that DAO contract was that the language team, basically, you look at the Solidity, read the docs, you would see that there is a very long section on sort of design patterns, that you should not be sending a transaction or a message to an outside contract and then trying to change the state of the contract. They always recommend you that if you have to reach out to a different contract, you do it as the last step of the function, not in the middle. But our idea was that why not restrict that at the language level? So you just prevent people from processing a transaction message in the middle of a function call. You just prevent that at the language level. You can do that very easily. So this is one, for example, where we felt that you could restrict the language in a way that it prevents some of these security bugs that often pop up, because you can't rely on developers and hope that they're gonna abide by the security recommendations that you put on your documentation website. So we made some sort of restriction on the language with the hope that those mistakes cannot happen. And we clearly felt that there's sort of a trade-off between how expressive a language can be and how auditable it can be. So the more expressive a language is, the less, the more complicated it becomes for you to audit and guarantee that the contract is safe. So when we designed this language, our own language called Scilla, it was designed on those principles that you remove things that are not necessary, and you allow people to write contracts in a way that they feel they're somewhat forced to think. For example, in Solidity, there's no clear distinction between what a library is and what a contract is. By the way, library is something that does not manage state. It's just a purely mathematical construct. While in Scilla, we basically defined very clearly that here's how you define your library, and your library code cannot sort of mingle up with let's say, a code that has side effects. And by doing all of this, we made a language that it becomes much easier for you to sort of write safe contracts. At the same time, it becomes possible to formally verify your contract, and that's very powerful. So that's kind of the reasoning behind why we started Scilla, and why we feel that Scilla is going to be a good language for people to use. And again, some people obviously sort of argue that, why invent a new language? It's very painful for people to write code, and there's a learning curve and so on. Well, talk to any developer. Any developer today knows at least 3 or 4 languages. And again, when you know one language, it's not like English and Chinese or let's say, I don't know, Hindi. Languages are very similar. So if you know, let's say, how to code in one language, it's very easy for you to sort of learn other language, because in the end, these are all mathematical languages, much easier to pick up. So my argument to those concerns are that you have at least 600 languages in computer programming, and a developer at least knows 5 languages. So you have to give people an option to write contracts that they feel could be safer compared to Solidity, and that's kind of the reason why I still believe that Scilla could be a good choice for people.
Yeah, and I can second that, at least from my experience. I also write contracts. And for example, if we take the DAO hack that you just mentioned, it was actually just one line that you needed to switch, and then everything would have been all right. Like, millions of dollars would have been saved. And this is, of course, the language that allows this. And a clever way to find a countermeasure here is to design a language that does not allow to do such a error or a mistake. Because, of course, you can have libraries like the Ethereum ecosystem has right now with the Open Zeppelin libraries and so on. And you have very well documented resources out there that are, you will basically find everything. But this is at the same time the challenge, that you need to read through all of this to avoid the mistakes in the first place. It is better, of course, to have something that, does not allow you to do this mistake at all, instead of asking you to pay attention not to do it.
Since you talked about libraries, obviously Open Zeppelin has I think very standard library that we all love and use, safe math, for example, right? How to do integer additions, how to do multiplication of large numbers in contracts. What we felt that, okay, sure, you can write libraries, but why not integrate that at the language level directly? So what we did was we integrated the safe math library directly within the language. And in fact, it helped us very recently, actually. So this way, whenever you write, you're doing an arithmetic operation, if it overflows, the contract will basically throw an error. So it's not going to assign a negative number when you're trying to multiply two positive numbers. And so these are kind of things that we felt that it could be inserted directly at the language level, so that people won't have to worry. And it literally saved us. Very recently, we wrote a contract where there was an overflow that happened, but nothing happened because the contract basically threw an error. So it basically stopped working because it protected users from an overflow bug. So that, I think, kind of one example of why I feel that those things could have been pushed to the language level, instead of hoping that Open Zeppelin and other people will develop libraries for people to use.
Shira, I have a quite specific question that just came to my mind. If we look at Ethereum, many people don't know that you actually don't move any tokens. What you actually do is just mapping an address to a number. So there is no actual movement that is happening. Blockchain like Libra or Diem, how they are called nowadays, they have this idea of first-class citizen tokens. So where they actually have on the, let's say, ground level, a function that allows you to move, and this is also how they call the language, to move tokens. How is this handled in Scilla and also in Zilliqa?
So in Scilla, it's very similar to Ethereum model, where your state of the contract has basically a map, as you mentioned, which basically keeps track of the different addresses and the number of tokens that are held under that address. And by under, I basically mean, as you said, mapping between address and the token numbers. And since you mentioned Move, it's very interesting because, and I think there are other languages as well. I think Algorand, if I'm not wrong, has its own language where tokens are first-class citizens. And it's very powerful, especially in the Move language, which Facebook launched, is that everything is a contract. So you don't have the notion as you have in Ethereum, and even on Zilliqa today, you have externally owned accounts, and then you have the contract accounts. So there's no difference between in Move, which is I think it's an interesting design choice because in the end, I think even today we are seeing wallets which are basically smart contracts. Argent wallet that was developed on Ethereum, it's a contract, and we are planning to develop something similar for Zilliqa as well. So in the end, a lot of people are realizing that obviously contracts can serve as regular address in some way, and so that design choice, I think I'm quite interested in how that flows. Unfortunately, we'll have to see how Move comes out in the end. But I'm very intrigued about that design choice, and I like it in some way.
Yeah, I have so many questions how this actually works right now in Zilliqa. I just got excited to learn about all of this. But we have another call next week, another show with one of your elite engineers where we will talk about these things. So for now, we will do a short break, and then we will come back and then actually talk about all the applications that are enabled through a blockchain that is already utilizing sharding and that is already scalable. And learn more about the ecosystem of Zilliqa.
Definitely.
Where are we heading? Who owns your data? Who owns your money? Your future. We are approaching a new dawn. Blockchain technology. Artificial intelligence. Sustainability. Part of the evolution. Hamburg, Germany, 2021.
Welcome back. You've just seen the trailer to our BlockChancE conference, which is hopefully happening in December this year. If you're interested in joining us, please subscribe to our newsletter. You can win a ticket that is worth 300 euros. You will find the address here somewhere. And now let's get back to the topic and talk about the ecosystem of Zilliqa and what kind of projects are running there. And I would like to start with a very practical question. How much do I actually pay on Zilliqa to send my friend these $5?
You'd be paying 0.002 zills, and 1 zill is I think around 20 cents. So it's tiny. Looking at your going back to your argument the other last time when you said for a $10 transaction you paid $8 transaction you pay $9 or something. So yeah, you don't have to worry about that fees part on Zilliqa.
Fantastic. So I will walk back to my friend and send her some Zill to show that it's actually already usable. And another thing that especially the Ethereum ecosystem, but I guess even also the broader ecosystem is interested in is the DeFi space. And in the DeFi space, we have this two big challenges, at least from my perspective. The first one is the lack of composability on the other blockchains that are out there, and also the lack of interoperability. And because right now you need to be basically on Ethereum because everything is there. But how could other blockchains, especially Zilliqa, actually connect to these to this ecosystem that already exists? And what are your plans here?
Yeah, so I somewhat disagree a little bit with your point, Albert. One is that today, for example, and I've been mentioning this a couple of times over the last week or so. So for those who might be listening to me second time, you might hear the same argument. If you look at, for example, the total number of users, total number of addresses on Ethereum that have non-zero Ether in that address, there are around 140 million addresses. Now, if you look at the total number of, let's say, people who are engaged in DeFi today, especially, for example, if you take the biggest DeFi app today, which is, I suppose, Uniswap, given that it enables the marketplace where you can imagine swapping everything for everything. The daily active number of users there on that platform, number of traders who trade on that platform is around 100K, around that mark. So that gives you a sense of the fraction of people who are actually engaged with DeFi activities today. Again, even if you add all of them up together, it's still not going to be half of 140 million. So the point I'm trying to make here is that the number of people, so they are probably 90% or even probably larger number of people who hold Ether, but who have never used any of the DeFi dApps today. Which kind of begs the question is, what are these people doing and why that's not happening? And I also wanted to understand this from our own ecosystem space. So our own community, what they're doing. I mean, maybe Ethereum community is too smart to use. I mean, they're very smart, and that's exactly why we're using DeFi, or is it because there's something wrong happening? So what I did was I was very careful into looking into our own ecosystem and see how many people actually engage in the DeFi activities that we do today on top of Zilliqa. And we try to compare numbers. So one in terms of TVL. So I was only looking at DEXs because DEX is one of the main things that basically drives everything on DeFi. So I was looking at all the DEXs today on Ethereum today and ranked them by TVL. And we recently had launched a DEX called ZilSwap, very similar to Ethereum, very similar to Uniswap. At least some would say that it's a little bit backward in terms of Uniswap because we don't have a separate dedicated pool in that sense. So it's all one single contract instead of having separate contracts. So even with that contract that we launched, within a matter of 4 months, we were able to see a total value logged of around $200 million. And that too with probably mainly 3 tokens. Now, how does it stand against all the DEXs that are out there against on Ethereum? So of course, Uniswap is the biggest. It has over 1 billion, if not more, TVL. But in terms of ranking, ZilSwap stands somewhere between number 6 and number 7. That kind of tells you that there's still a lot of users out there outside of Ethereum. They are not given, or have not even ever used any of the DeFi dApps that are out there. So there's still a demand. There's still a consumer base that's sitting on different chains, whether it be Zilliqa, whether it be Tron, or even if you look at Tron, the number of transactions happening on USDT Tron is actually pretty close now to Ethereum. And every time Ethereum gas prices go up, those two charts become closer and closer. So I mean, all I'm saying is that there's still a community outside of Ethereum that's actually using DeFi. Of course, that number maybe is smaller, but still it's substantial. It's not something that you can ignore. So that's one thing. Obviously, we started out on DeFi. We started with DEX contract where we saw that we saw a good interest from the Zilliqa community into getting involved in those DeFi activities. We also launched now something like a Make a DAO contract for stable coins, except that we decided not to. I mean, the developer decided not to use MKR token, so they were using a token that we have called the GZO. So it's a token for at the protocol layer, so you can use that token to decide at the protocol level, but at the same time, probably the first design where you use that token even as a governance token, even at the application layer. So you're basically lifting that up as well. So we saw some of these activities, and I'm quite surprised to see that there are a lot of users outside of Ethereum that are looking into DeFi, or at least even entering into DeFi on their own chains that they love and like. I'm sorry if I digressed from your original question, but
No, that's completely fine, because I think this is a very interesting insight, because most of the time when we talk about the dominant blockchains out there, it's of course Ethereum and Bitcoin, and the people that are talking about it are heavily invested in this blockchain. And let's say if they really know what they're doing, they are also explaining it to other people. But this does not mean that we don't have the chance to actually onboard complete new users that don't know anything about DeFi yet, and they don't need to be onboarded on Ethereum. They might just be onboarded there because we don't really look at the numbers, and we look just in total value. And this is of course for the first mover easy to lead here, but other blockchains have an opportunity too. And one way to actually make this easier also for the user especially is by increasing interoperability, so that you don't really have to care where you're running. You want to do or use a specific app or dApp. And I also know that you are, I think just recently, right, you joined Polynet, or even are active there now. Is it live already, and what is the plan there?
So yeah, Polynet is, and again, this is a very good question. That's kind of what sort of decided, and we may like and hate as much as we want Binance Smart Chain, but it definitely showed to people that there is a user base outside of Ethereum, or at least there's a user base even on Ethereum that's interested in moving out of Ethereum because of some of the issues, whether it could be gas fees, for example. So we have been looking into interoperability as well. So we are working with this partner called Polynet, which basically builds a network of relayers between two different chains. So you have Zilliqa on one side, you have Ethereum on the other side, and you have Polynet that sits in between. So we have successfully integrated with them, and basically once you integrate with something like a Polynet, they give you transitive access to other chains. So for example, if they are connected with Bitcoin, you get connected to Bitcoin. If they are connected to Ethereum, you get connected to Ethereum as well. So we are at a stage where we have finished integrating with the testnet. And the idea is now to be able to open that testnet along with an interface for people to try out and let us know if they find any bug or issue on our end. And once the committee is convinced that there doesn't seem to be many bugs, then we will open it into production. So that's kind of where we stand today with interoperability. And I firmly believe that once that happens, the hope is that we'll have assets like BTC and ETH, which will be able to move from their source chains to Zilliqa, and people will be able to transact and transfer them around on the Zilliqa chain at a cheaper fee. So that's kind of what the intention is.
And what kind of trade-offs are there if you connect to a network like Polynet? Do you sacrifice any of your properties like security, speed, scalability, or anything?
Well, there could be challenges in some forms. If, let's say, for example, there's one chain that's very fast, the other chain is very slow, then things can become a little bit challenging sometimes. So that's probably one challenge. The other point is about you're relying on a third party. So you need to make sure that the third party network is safe. The third party network runs the consensus in a good way and in a healthy way. Their network doesn't get, let's say, attacked for some reason. So that's kind of the reliance that you have when you connect with a third party, for sure.
And are there any other plans to connect to any other third parties, let's say like Matic or Polygon or?
So we have intentions. We have been talking to a few other parties just to make sure that we have alternatives for people if they wanted to. And there is a team in Korea that is, I think they have developed something called Orbit, which is, the difference with Matic is that it allows you to connect, if I'm not wrong, it allows you to connect to the Matic chain and Ethereum, so basically EVM compatible chains. And what I'm talking about are potentially non-EVM compatible chains. So Orbit is one chain where Orbit is another example like Polynet that allows you to connect between Zilliqa with any other chain out there, as long as the other chains have connected to their network. So that's another sort of alternative that we are looking at. But yeah, one after the other. Otherwise,
yes, definitely. And I think what the users most of the time will care about is, okay, can I use it now? And just recently, we have, of course, this NFT hype that is happening. And also, of course, Zilliqa, since it's a smart contract platform, also supports NFTs. And you have this great event with this heavyweight champion. How did this actually happen, and how is this all of this connected to blockchain, and what kind of advantages do you see to invest time into such how to call it, auction?
Yeah, so the reason why I would say auctions or NFTs are becoming popular today is one reason is because people are, at least big celebrities or even, let's say, artists, or whether it be people designing painting, or people doing paintings, or people creating let's say music, or those sort of things. So these people, they clearly see that there are middlemen that sit between. Let's say if you want to auction painting, it's an auction house that sits in between, and sometimes those auction houses actually charge you a hefty fee on both sides. And so you're basically relying on an auction house to, and again, you have to convince an auction house to auction your work, which sometimes for young artists it's very complicated and very difficult. So the idea is, can you build a marketplace where these people can auction or even sell simply their artwork or their digital work, basically? And that's why I think NFTs are becoming popular. The other reason is around celebrities. Celebrities obviously know that whether it be sportsmen or whether it be, again, song musicians and so on, they have a long sort of supply chain between them and their consumers before they can get their money. So these people are obviously looking at ways in which they could monetize themselves better. And we have even come at a point where there are celebrities who are actually talking to their fans, and these fans are even interested in sort of voting. And those voting actually requires you to put some capital on top, so you have to pay to be able to vote. And these celebrities basically are asking their fans to decide, different things for their life. For example, as mundane as whether they should wear a black shoe or a brown shoe. So these sort of fan engagement is something that's becoming interesting, especially in the post-COVID world, where it's very difficult for you to go out in the crowd, and fans and celebrities are looking into ways in which they could engage in a much better way with their fans. So that's another reason why I think the NFT marketplace is becoming popular, and people, including, for example, when we started to work with Terence Crawford, who is one of the undefeated champions in the world, where the idea was he wanted to give something back. He wanted to basically connect with his fans and give them something, at the same time be able to monetize himself. So that's kind of one way of thinking about it. But again, there are multiple benefits of NFTs, including, for example, the provenance, right, which is a key factor in artwork. So today you buy a painting and you're not sure where this painting came from. And if that provenance can be established on a blockchain, which remains immutable, that adds value to the painting and also to the buyer.
And that's what's super interesting to me, because what we're seeing right now, we are seeing all the hype around the price, of course, of NFTs. So we have this attention from the media that is always coming to blockchain once the price goes up, or if it crashes heavily. But now we can use this actually to show people that you can utilize these NFTs for social activities. You can actually do something completely different that is not really related to money, but that is related to value. And I think this transition from money to value is quite important, because we created a protocol to communicate value, not necessarily money. This was just the very first application established through Bitcoin and driven through a lot of memes. But this is definitely not the only thing that we can do. And recently you also had a big announcement of Zilliqa Capital, that is supporting different projects and companies that want to build on top of Zilliqa. What kind of projects are actually applying there? And what kind of projects are you looking for to support the ecosystem?
Right. So, when we started let's say, when the mainnet, Zilliqa mainnet was launched, we had seen some interesting, really good projects coming up on Zilliqa. One of the first ones was Unstoppable Domains, which is a domain name system very similar to ENS. Then we saw projects like ZilSwap that came up. We saw that is actually being run and managed by a company called Switcheo. We saw Mintable, which is an NFT marketplace, coming up. And basically, in general, what we basically saw that these projects initially got funding from Zilliqa Research, and then later on, got funding from Tim Draper in case of Unstoppable Domains. They got funding from Mark Cuban in case of Mintable. They got funding from Three Arrows Capital based in Singapore for Switcheo, and so on. So we clearly saw that we were able to. There are some really good developers and projects coming out of the Zilliqa ecosystem, and once you give them initial grant, they would like to get some later funding at some point. And the idea was to with Zilliqa Capital, was to set up an ecosystem fund that could be used to give or put out big ticket checks to those projects who do well, whether it be starting from seed round investments to up to even Series A or even beyond. So that was kind of the motivation behind Zilliqa Capital. We're also seeing that the other motivation was that we're seeing projects coming out of Singapore, India, and Malaysia. I don't know if all your followers know or the viewers know. A lot of good projects like Etherscan is something that came out of Asia, Malaysia. And so we're seeing a lot of these good projects coming out of the region. CoinGecko, for example, is a Malaysian project, is an Asian project. So we're seeing all these good projects coming out of Southeast Asia, but the funding for those projects was still very lackluster in some sense. So it was very difficult for them to get funding because most of the funding used to come from, or at least even now, comes from Silicon Valley. So by the time you reach out to Silicon Valley folks and convince them to put some money and capital for your project, you are basically dry. Your energy is basically dried. You don't have much energy left to take your project through. So we felt that it would be good for us to establish a sort of ecosystem vehicle that would sit in that region and be able to selectively pick projects from that region and bridge that gap that people have or people find between VCs in Southeast Asia and VCs in Silicon Valley. So that was kind of the intention. Again, the reason why Zilliqa Capital is named Zilliqa and why it's closer to Zilliqa as a company is because when you're close to a blockchain platform, you can actually notice projects like Unstoppable Domains, projects like Mintable, which is a NFT marketplace, and that's kind of the projects we will be investing in, mostly around DeFi, but also around NFTs in the long run, coming out of those regions in particular. But again, blockchains have no boundaries, and therefore we won't have boundaries either.
So with all these opportunities that you can invest into all these different projects, the question is, of course, for me at least, how do you envision a desirable future? So what kind of projects do you want to see succeed? For example, we look at Cardano, how they unite their communities through a grand vision that they have and a technology that is still under progress, let's call it this way. And in Ethereum, we have this hope of Ethereum 2, so people are working towards that. And what is actually, or is there something for Zilliqa that you work towards? Like, is there something like Zilliqa 2.0, or are you rather going a route where you just improve in an iterative fashion and don't promise something that is far away in the future, and rather look at how you can change the world now?
Yeah, so our approach and team's approach towards this is very clear. We are at a stage where we have developed a platform that's functioning. There are at least 100,000 users using all sorts of platform, all sorts of DeFi, dApps. Staking alone, for example, has over 70,000 people, actively using that application. So we have a lot of users who are using these applications, and the idea is to show them and to get feedback from them that what's working and what's not, and then improve that as we move along. So that people would see that if they feel that something is not working in terms of their features missing, within the next cycle or two, whenever we get, depending on how complicated that feature is to implement, they would see that feature getting implemented as soon as possible. For example, a lot of people were complaining to us when we launched staking was that they were not able to switch off or, let's say, move their staking address to another address. So, for example, if you're using a key store wallet, and for some reason you wanted to, and for good reasons, you wanted to move from Keystore to a Ledger wallet, you couldn't do that. If you wanted to do that, you had to go through an onboarding period of 2 weeks, and that was painful, and therefore no one wanted to do that. So this feature is something that sort of came up via the community, and we felt that is something that we should add. So we decided to sort of add that feature into staking. That's hopefully going to come very soon after this. So our approach to software development today is seeing what community uses and seeing what community likes, and then building sort of adding those features and adding those dApps towards for people to use. In terms of Zilliqa 2.0, we definitely believe in something that will improve over time, and we are working towards that. But it's not something like Zilliqa 2.0 is going to come in December 2021. Zilliqa 2.0 is going to come in phases, where you will every month or two you will see different improvements coming on. For example, when we started working on Zilliqa back in the day, we had this smart contract language called Scilla, and due to certain design decisions, we decided that we are going to write an interpreter for that language. And as you know, interpreters are generally very slow, or sometimes slower compared to a compiler. So now we are, for example, working on removing that interpreter and replacing that by a compiler. So hopefully the time it takes to process a transaction, particularly a smart contract transaction, will be much faster now. So, and these are very big changes, right? Moving from interpreters to compiler is a huge work. And the idea is that these are things that are going to keep coming up every quarter or so that you can see the changes that are coming up. And instead of making 5-year roadmap or plans that are going to change within the quarter, it doesn't make sense. You talk about DeFi, no one was talking about DeFi, or at least not actively, a year ago or 2 years ago. So DeFi naturally came up organically, and then people started to talk about and work on, okay, what next to build? That was kind of the model in which we are sort of looking at. So we look at what's working today, what else we can build, and that we are going to do it in an incremental manner rather than promising, 5-year roadmap and sort of changing it every quarter. That's not something that we believe in. And the good thing is that we believe that whatever we do, the community will see it immediately, either by using it or by giving us feedback. Look, that you push this feature, we like it, but we hate this aspect of this feature. So we would rather engage with the community and sort of shape our roadmap as we move along, rather than impose a roadmap to them.
And you started this project with a heavy background in academia, and you had this research-driven approach to develop things. Is this still something how you would describe your development, or has it moved more into, let's say, Silicon Valley style, break things fast?
Yeah, no, we're still in that mode. For example, we have seen in the Ethereum ecosystem people publishing blog posts with ideas which are neither which neither comes with any rigorous claims or rigorous proofs. Sometimes they're even flawed, and you won't know that until you spend 9 months on this and then realize that that's not working or that's completely flawed. So our idea, for example, recently we were working on the smart contract sharding idea, where we wanted to see if we can leverage some of the language capabilities to better shard smart contracts. And the idea was not to put out a blog post immediately and say, okay, let's go and implement that. I feel that it's a good idea to actually spend some time. So we spent at least 6 months doing proper academic research, and we then published that paper into one of the top conferences in programming languages. And we got some very good feedback from academics who are experts in the field. And now that we have a paper, which obviously while doing that paper, we also implemented something, let's call it a proof of concept, that gave us a sense that, okay, our idea is not just theoretical, it actually even in this lab setting, it still works. So that gave us a lot of confidence that we don't have to revisit this paper again. Or if we spend 6 more months on this, it's going to go for waste. That's not, that often happens when you write your ideas and don't spend enough time on vetting your idea and do rigorous work in a blog post like idea. So we are still in a model where we spend time writing a proper academic paper of 20 pages long. Again, it's not about the length, but it's about rigor that we sort of impose ourselves on. And once that rigor, we are satisfied with that rigor, once other people who have peer reviewed that work, they are satisfied with what we're doing, then we go and implement that. And that's kind of the approach that we still have.
Super interesting to see that, because exactly as you described, in the Ethereum world, it feels also more approachable because of that, because everybody can bring in their ideas, but there are just so many of them. And if you just start to look at them in detail, then many of them fall apart. And some of them are so complicated that you would actually need this 9 months or even longer to properly say if this is a good idea or not. And so it's not that you can just implement this in a quick manner and then see if it works or not. The system is too big right now to actually,
and we are handling hundreds of millions of dollars worth of assets for people. So we have to, and I keep saying this a lot of times, that we have to be responsible developers. We can't keep coding smart contracts over a weekend and then put it out in public and say, let's go wild with it, and expect that people then go crazy and then put $100 million within a matter of hours, and then we decide, oh, we found a bug there, and everyone's money is lost. So we have to be responsible developers as well. I think again, this might be a little bit opposite of what Ethereum ecosystem does, but we firmly believe that given that we all come from, many of the people in the Zilliqa team come from academic background, and we feel that it gives us a lot of confidence when you do a bit of rigorous research before you actually start implementing it. So that's kind of the confidence that we want to have ourselves, and then we would like to convey that confidence to the people who are risking their capital into our systems.
And one question that we ask here at Blockchains over and over again is in the regard of energy consumption. We haven't talked about this at all. So what is actually what you describe as eco-friendly dual mining? What does this mean, and how does the blockchain scale in the future? So will we ever see an energy consumption like in Bitcoin? Or and if yes, is this a bad thing, or what kind of opportunities are enabled if let's say Zilliqa becomes like the new world computer that everybody uses?
Yeah, so the way Zilliqa takes proof of work is very different from Bitcoin, for example, let's say, or even Ethereum today. So when you, let's say, in Bitcoin, when you process a transaction or you process a bunch of transactions in the form of a block, every miner, or at least one miner, comes up with a proof of work, and then basically that repeats for every single block. So basically, in simple terms, every single block needs proof of work. That's kind of the baseline. You can't avoid that. You cannot get away from that. In Zilliqa, we do it differently, in the sense that we need proof of work only to create that randomness that I was talking about earlier, to create that, to assign different nodes to different shards. And once we have that network set up, you don't need proof of work. So in fact, we saw that if you use classical BFT algorithms, so Byzantine fault-tolerant algorithms, then they can actually become much more faster in processing transactions. So if you run BFT within, let's say, a network of even 600 nodes that we do, it doesn't take more than a few milliseconds, or probably tens of milliseconds, to get a transaction value or get a block of transaction validated. That's much faster than proof of work. So in short, Zilliqa is better than in Bitcoin in terms of proof of work, because your proof of work is required only when you reconstruct that network, which happens roughly every 2 hours. So roughly every 2 hours, the network basically reshuffles, and then everyone does proof of work, and then people are assigned, nodes are assigned to different shards. And once you are assigned, then you switch off your proof of work, and then you start using BFT, which is a voting mechanism. So that's kind of how Zilliqa differentiates itself from Bitcoin in terms of proof of work. Now, this proof of work versus proof of stake and so on, it's a debate where you have both schools of thoughts, where one school says that you could also say that, and we are seeing that already in many chains, proof of stake chains. You have big players like Binance, Coinbase, and so on, holding substantial amount of stake in the system, and if they decide, a lot of things can happen. And this we saw, I think, in that Steemit case last time. So there are definitely challenges that people still have to figure out, but the bottom line is the two, proof of stake and proof of work, they offer different guarantees. So they rely on different security assumptions, and therefore they have different guarantees in some sense. So saying that one is good and one is bad, I'm not sure, but yeah, they're definitely schools of thoughts, and there are definitely pros and cons on both sides. So that's kind of my take on it.
Yeah, thanks for this detailed explanation. And we are also towards the end of the show. And what I would like to try together with you, maybe to summarize what we discussed today, to give a quick overview of all the different points. So we started with explaining or giving a brief overview of the Zilliqa history, how this was actually launched already back in 2019. But before that, we already had like 2 years of academic research that was happening. So you already had something. Not just a white paper, but actually also proper research that you've done. We moved on to explaining what sharding is. We used this idea or this metaphor of the light bulb in the house and the living room. And I think, this sticks with many people in their heads now. And they have at least a basic understanding of how this works. And then in detail, we will understand how this works next week when we talk about all the technical aspects of this. We also discovered that it might be useful to actually have your own language, and that it's not such a big drawback as it always is put out there, because we as programmers already speak a lot of languages. So it's not like we need to learn, as you said, a new natural language like Hindi or German or whatever. It's much, much easier than that. And also what it allows us to avoid certain mistakes. And these mistakes could be avoided in, let's say, Solidity only if I read through all the documentation. So I spent time anyway to learn this properly. Then we talked about the challenges of the Zilliqa platform, or let's say, of the current and also of the current project. So what are you heading towards next? So there is something like Zilliqa 2.0, but it's not like on a fixed date. You are rather looking for constant improvement. And this also allows you to actually react to the community and not just follow your vision that you have set 2 years ago, let's say. And what I'm really excited about is that we have all this NFT hype right now that we can use to actually transition to other use cases of blockchain. And you are using this with the Terence Crawford NFT that is auctioned, I think, in 2 days or 3 days, something like that.
I think it is already on auction, so I think it's closing in a week.
Yeah. Exactly. It closes in a week or something, or I think even just 3 days. So if you're interested in that,
time passes so quickly.
Yes, you should have a look there. And you also connected Zilliqa to the Polynet. So you're right now on the test net. So checking if everything is working so that you can go onto the mainnet there and have this interoperability, that the user needs to care less and less about where they are actually, and they can focus on using the applications. These applications are mainly built through the community projects, and you're also actively supporting this with Zilliqa Capital, which looks for big projects like Mintable, that is, as you said, also already supported by celebrities like Mark Cuban. So this is definitely something that is in the mainstream. And we're not just talking to us geeks anymore, like in, let's say, 2017, where we also had kind of mainstream or at least attention, but not really any kind of adoption, I'd say. This is, in my opinion,
Cuban, by the way, he will surprise you if you talk to him. He came very late. I mean, you could argue that he came very late, joined very late, but the kind of I think he has gotten his hands quite dirty in the crypto world, and he would surprise you.
I believe so. Maybe we can also have him in the show here one day. This would be also super interesting to see how these VCs from rather the old but still tech world jump into Ethereum and Zilliqa and this blockchain space. And then we also discussed how we envision the future. And here we are both on the same side, that we think it's really the users that matter. And that it's not just everybody's on Ethereum and everybody will stay on Ethereum. There is this tribalism, which I completely hate. And I think most users don't care for this tribalism. They will just use something. And if technologies are already working like Zilliqa is, there is a good opportunity that you can actually get adoption here.
Yeah, I mean, there are, I don't know if you have still time left.
Yeah, sure. Yeah.
One thing that I wanted to highlight was that, again, in terms of users, we saw smart, buying a smart chain sort of attracting considerable number of users. The other problem that I see in DeFi spaces is around, when DeFi started, we had the vision that we are going to bank the unbanked, and we are going to help people who don't have access to financial services, because that's what DeFi promises. You only need a smartphone and internet connection, and then you are good to go. That was kind of the vision. But if you look today and try to understand, look at all the DeFi products that are on Ethereum in particular, because that's where a lot of users are, in fact. And so if you look at there and see, okay, how many people are coming from, how many of those users are coming from those, let's say, developing markets or emerging economies, and the percent is less than 5%. That kind of gives you a sense of how far we are in terms of pushing this to the main mass. So in a way, all the users, or at least big majority of users who are using any of these DeFi products, they are mostly coming from developed countries who already have access to all sorts of financial products today. So there is definitely a lack, we are missing, or we are not creating the right product for the right people sometimes. So we also have to understand how to make this DeFi product more accessible to people. Is it because these people don't have good access to on-ramp services? Are they not able to convert their fiat to crypto? Or is it because there's not enough marketing in those markets? People are only focused in some who call themselves DeFi degens. So there is definitely DeFi definitely has a first world problem. I think that's the right way to put it. It has a first world problem, and we have to figure out how to fix them.
And I couldn't end the show better than this. I think this is a good summary of the current state of blockchains like Ethereum, and how blockchains like Zilliqa could actually profit real world users, and that we promised to help with all this blockchain vision back like 6 years ago or even longer, where we always try to convince people with banking the unbanked. and nowadays, as we discussed, it's almost impossible to use Ethereum as someone who could be considered unbanked. So thank you very much, Amrit, for your time. It was a very interesting discussion, and I think also our audience learned quite a lot. And I'm really excited to talk next week to June Hao, the Senior Vice President and also one of your co-founders of Zilliqa, and do a deep dive into the technology that we just strived on the surface today.
Thank you very much for inviting me over. It was lovely being here. I'm sure you'll enjoy talking to you now as well.
Thank you very much. Have a great day, everyone.